So in this video, I wanted to look at how you can look at a polynomial function. This is an example of a really long one. How can you tell and determine the end behavior of the graph of the function? Obviously, this would be pretty long to figure out how to graph. But we can look at this and figure out the end behavior. And that means whatever the graph is, how it ends as it goes as x is approaching negative infinity or positive infinity, or we like to say sometimes to the left and to the right. Okay, but one thing we know about polynomials is the end behavior is either going to go up to infinity or down to infinity. Okay, so looking at this, and this is helpful when you're trying to sketch the graph of a polynomial to know the end behavior. What we're going to start with, and I wrote this, the leading term tells us everything about the end behavior. So what's the leading term? The leading term is the term with the largest degree. That's the leading term, okay? And even though this is a long polynomial, right, the first term tells us everything we need to know about the end behavior. Okay, so there's two things to look at. First, we're going to look at the coefficient. Right there, the number before x to the fifth, in that case, is 2. So look at the coefficient, which in this case for our example is 2, right? That equals 2. Okay, so very simply, if this number is positive, right? If, I'll just put a plus for positive, right? Then the graph goes up to the right. Okay, so the coefficient tells us how this function, when we graph it, is going to head, what direction as we go to infinity, right? On the right side of the graph. Okay. If the coefficient is negative, then it goes down. Makes sense? Very simple. Okay, so just look at the coefficient, and since it was positive 2, we know that it went up. Okay. So that's the coefficient. Second thing you're going to look at is you're going to look at the degree of the polynomial. The degree is the main exponent. The largest exponent tells you the degree. It's either going to be even or odd. Okay? So next, let's look at the degree. And remember, the degree is just the exponent of leading term. The largest exponent, okay? So in this case, okay, the degree is 5. Okay, now about the degree, okay, if the degree is even, right, then same directions. They go in the same directions. They either go both up or both down. If degree is is odd, then opposite. Makes sense, opposite directions. Okay, so when I look at this, and I have an example like the one I gave you, I particularly choose to look at the coefficient first so we know which way it ends to the right, either up or down. And then the degree tells us it's either going to go the same way or opposite. Okay, so let's look at this example really quickly again. Okay, so for this example right there, I'll do it down here. Okay, my coefficient was 2. Okay, and that means because this was positive, right? Positive means it ends up to the right. Okay, and look at the degree. So next, let's look at the degree, right? The degree is 5. That is odd. See, you won't ever have a negative degree, so the coefficient could be positive or negative, but the degree, we're talking about either even or odd. So odd means opposite Just remember the odd and opposite, the O's go together, okay? Which means if we know that it ends this way to the right, then to the left, it goes the opposite way, okay? So this is my end behavior, okay? So no matter, we don't know what the graph really looks like, okay, of this long graph, but we do know what happens on the ends. As x approaches negative infinity, it goes down forever to infinity, to negative infinity. And as x is going to the right, approaches positive infinity, this function goes up to the right. This is my end behavior. Okay? Okay, I hope that made sense. Let's look at a few examples quickly. I have 2 examples here. Okay, determine the end behavior of this. Okay, I've just given you some random polynomial. We're only looking for the end behavior. Okay, so remember what we do. We look at the leading term. Okay, 2 things to look at. First, I'm going to look at the coefficient. We'll abbreviate that. It is -4. So remember, the fact that it's negative means that this function, as we're graphing it to the right, it's going to go down eventually forever to infinity, to negative infinity. Sorry, down to negative infinity. Now let's look at the degree. We have a 6, right? This 6, which is even. Even means same. All right, so since that was going down, that means to the left it's going down too. So that's the end behavior of this graph. Okay, let's look at right here. This is just, a quadratic, right? A parabola. We kind of probably already know what that is. You most likely probably know. The graph of a quadratic is a parabola, which looks like a horseshoe. But let's apply these rules. So determine the end behavior. Let's look at the leading term. First, the coefficient, right, is -3. Okay, so it's negative, which means it goes down. Okay, then let's look at the degree. 2, which is even. Just like the last one, means same direction. Right, so they both go down. Now, like I said, when you see a quadratic, just x squared, we know that the graph of quadratics are parabolas. And you can tell by the leading term, if it's negative, we know this graph looks like that. Okay, so my end behavior was both down. Okay, let's look at one more example to finish this off. This will come up maybe later in another section when we have to, look at the graph and try to figure out what the graph is. This is a pretty big polynomial and it's in factored form. Okay, so it's not quite, you can't just look at it and tell what the end behavior, what the leading term is. Okay, so you could multiply everything out, but you would have to FOIL this out, and then this one is squared, so you'd have to FOIL that out, and then it would be a very long polynomial. But remember, for end behavior, all you need to worry about is the leading term. Okay, well, since each of these factors are being multiplied, what you can do is a shortcut is take the leading term of each factor and multiply it together. That'll give you the leading term of the whole polynomial. Okay, so let's look at the first factor, x minus 4. The leading term is x, because x is a larger term than just -4. All right, so leading term is x. And this is being multiplied, right? So we'll do the same thing. Let's do the leading term of 2x minus 1. Okay, the leading term is 2x. There. And then lastly, you have x minus 3, but it's squared. Okay, so you have to think to yourself, x minus 3 squared, if you were to multiply that out, the leading term would be x squared. Right there. So my leading term is x squared. Okay, if you multiply the leading term of each individual factor, if you multiply that together, you get 2x to the 4th. Okay, this is the leading term. If you wanted to come off to the side and multiply this completely out, it would be a very long polynomial, but this would be your leading term. Once again, for end behavior, this is all you need. So if I asked you to find the end behavior, we're just going to look at 2x to the 4th. Okay, same rules apply. Our first step is look at the coefficient. 2 is positive, which means it goes up to the right. So you got to find to the right first. Then in order to find the other way, you look at the degree to figure out if it's the same or opposite. So my degree is 4, which is even, which means the same, which means they both go up. So my end behavior of this polynomial, if we were to graph it, on the ends, they both go up towards infinity. Okay, hopefully that helps in determining end behavior.